Welcome to PreMath. In this video, we have got this right triangle BEC fully confined in a trapezoid ABCD, as you can see in this diagram, such that the side length of this right triangle BEC is 3y and this side length is 2y. And this hypotenuse of this right triangle BC is 13 units, and moreover this segment CD is x, and this segment AB is 2 times x. And now our task is to calculate the area of this purple trapezoid. Please don't forget to give a thumbs up and subscribe, and please keep in mind that this figure may not be 100% true to the scale. Let's go ahead and get started. And here's our very first step. Let's recall the definition of a trapezoid. Sometimes we call it trapezium, a quadrilateral with at least one pair of parallel sides. And here we can see this AB and CD are parallel to each other. And now let's recall the area of a trapezoid formula. Area equals to height h times the sum of the bases a plus b all over 2. And here in our case, this AD is going to be the height of this trapezoid. This is going to be our base lowercase a, and this is going to be our lowercase b base. So therefore, we must find the value of these bases a, b, and the height h as well. And now I'm going to label this segment AE as lowercase m, and this segment DE as lowercase n. And now let's focus on this right triangle BEC. And we are going to apply the Pythagorean theorem on this triangle to find the value of y. And here's our Pythagorean theorem: a square plus b square equal to c square. And in our case, our hypotenuse is 13, and our other two legs are 2 times y and 3 times y. And now we are going to fill in the blanks in this Pythagorean formula. So therefore, we got 2y whole square plus 3 times y whole square equal to 13 square. Let's divide both sides by 13. This 13 and 13 is gone, so therefore y square turns out to be equal to 13. Now I'm going to undo this square by taking square root on both sides. So therefore our y value turns out to be positive square root of 13. So therefore our y value turns out to be square root of 13. And now let's assume that alpha and beta are our two complementary angles. In other words, the sum of these two angles, alpha plus beta, must be equal to 90 degrees. So therefore, let's assume that this is our angle alpha. This is our 90-degree angle. So therefore, this angle has got to be our angle beta. And now we know that this is our 90-degree angle. This angle is beta. So therefore, this angle has got to be our angle alpha. This angle is 90 degrees. So therefore, this angle is going to be our angle beta. So therefore, we conclude that these two right triangles, this right triangle EAB and this other right triangle EDC, are our two similar triangles according to angle-angle similarity theorem. So therefore, we are going to have a proportion. In other words, the side opposite to this angle alpha is going to be this side AE, and the side opposite to this 90 degree is going to be this EB. Likewise, the side opposite to this angle alpha equal to this side CD, and the side opposite to this 90 degree is going to be this side EC. As you can see in this proportion, the ratio of EA divided by EB equals to the ratio of CD divided by EC. And here our AE length is lowercase m, EB is 3 times y, CD is x, and finally this EC is 2 times y, as you can see in this next step. And here we can see y and y cancels out, so therefore we are ended up with m divided by 3 equals to x divided by 2. And now I am going to multiply both sides by 2, and here we can see this 2 and 2 is gone, so therefore our x value turns out to be 2m divided by 3, and I'm going to call this our equation number 1. And here's our next step. Let's focus on these sides. This opposite to this angle beta is this 2x, and the opposite to this 90 degrees is 3y. And likewise, opposite to this angle beta is going to be this lowercase n, and opposite to this 90 degrees is 2 times y, as you can see in this proportion. And here we can see AB is 2x, EB is 3y, DE is lowercase n, and EC is 2y, as you can see in this next step. And now we can see this y and y are gone, so therefore we ended up with the 2x divided by 3 is going to be equal to n divided by 2. And now I'm going to multiply both sides by 3 divided by 2, and on this side 3 divided by 2 as well, to isolate x. And here we can see 2 and 2 is gone, 3 and 3 is gone, so therefore x turns out to be equal to 3 times n divided by 4. I'm going to label this one as our equation number 2. And here we are ended up with these two equations, equation 1 and equation 2. And now we are going to compare these two equations. We can see our left hand sides are identical, so we can equate the right hand sides as well. So therefore we are going to get 2 times m divided by 3 equal to 3 times n divided by 4. And now we are going to cross multiply, so therefore we are going to get 8 times n equals to 9 times n. And now we are going to divide both sides by 8n. Here we can see 8 and 8 is gone, so therefore m divided by n turns out to be equal to n, and n is gone on this side, so we are ended up with the 9 divided by 8. And here we can see the ratio of m and n is going to be equal to the ratio of 9 and 8. So therefore we conclude that m is going to be equal to 9 times some constant k, and n is going to be equal to 8 times some constant k. And now we are going to find the value of constant k. So therefore our this segment m turns out to be 9k, and this segment DE, which is n, turns out to be equal to 8k. And now let's focus on this equation 1. And here we have copied it down over here, and we know our m value is 9 times k, so therefore I'm going to substitute m for 9k over here. As you can see in this next step, I have replaced this m by 9k over here. And if we simplify the right hand side, x value turns out to be 6 times k. So therefore our this x value turns out to be 6 times k. If x value is 6 times k, then 2 times x is going to give us 12 times k. Now let's focus on this right triangle EAB. And now let's recall the Pythagorean triplets 3, 4, 5. If we multiply each and every number by 3 times constant k, then our new set of Pythagorean triplets are going to become 9k, 12k, and 15k across the board. And here we can see this leg is 9k, this leg is 12k, so therefore this hypotenuse has got to be 15 times k. So therefore we can see this side length EB is going to be 15 times K, and this side length EB is 3Y as well. So therefore we are going to equate them. I can write 15 times K equals to 3 times Y. Let's divide both sides by 15. So therefore K value turns out to be Y divided by 5. And we know our Y value is square root of 13. So therefore I'm going to substitute Y value as the square root of 13 over here. So therefore our K value turns out to be square root of 13 divided by 5. And here's our final step. Now we are going to calculate the area of this purple trapezoid. And now let's recall once again the area of a trapezoid formula, H times A plus B all over 2. And in our case, our base A is 12 times K, base B is 6 times K, and this height H is going to be 8K plus 9K is going to give us 17K. So let's go ahead and fill in the blanks in this formula. So H in our case is 17K divided by 2 times our A value is 12K, and then plus B value is 6 times K. And here in this next step, 12K plus 6K is going to give us 18K. 2 goes into 18K 9 times K. And here 17K times 9K is going to give us 153K square. And we know our K value is square root of 13 divided by 5. So I'm going to substitute K value over here. So therefore this is going to become 153 times K is square root of 13 divided by 5 whole square. And if we simplify everything, we are going to get 1989 divided by 25, and in terms of decimal that is going to be 79.56. So thus the area of this purple trapezoid ABCD turns out to be 79.56 square units. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.